In the final property, I told you that Gauss law cannot be applied for a dipole. Why? Because dipoles does not obey 1 by r square law. That means inverse square law. So suppose this is a dipole, this is minus q and this is positive q, and there is a small distance. So for that, field does not vary as 1 by r square. This is not true. We saw that field vary as 1 by r cube. So that is a departure from inverse square law. So Gauss law cannot be applied for a dipole. Again, let us see if we take this thing and there is a dipole that is inside this sphere. So this is minus q and this is positive q. So for Gauss law, so total flux is equal to charge enclosed upon epsilon naught. So total charge enclosed is minus and positive, hence 0. So again, the Gauss law cannot be applied for a dipole. Why? Because it shows a departure from inverse square law, as well as total charge enclosed is always 0. So hence there will be a no net flux because of this dipole. Okay. Now let us do a very simple example based on Gauss law. This example 1.1. So what is in this example? We have an origin O. We have three axes, x, y and z axis. There is a cube. Cube has a side A. This is a cube. It has a side A. Cube is kept at A distance from origin. A, another A. So that means this point is A distance, this point is A and A, 2A distance. So the cube is kept at A distance, positive A distance on x side from origin, and cube also has a side A. So let us understand this example. So there is a cube. The electric field components in figure 1.27, this is figure 1.27, are Ex. So what this is the electric field. So here you can see that electric field Ex is equal to simply alpha x to the power half. Alpha x to the power half. Ey and Ez are 0. That means electric field in this direction and electric field in this direction both are 0. That means there is no electric field in y and z direction. Only electric field is in x direction, which is given by alpha x to the power half. Alpha x to the power half. Now what is alpha? Alpha is a constant which is given here. Alpha is equal to 800 Newton per coulomb meter to the power half. Alpha is given like this. Now we have to calculate two things. The flux through the cube. So first thing is the flux phi, we need flux through the cube, and second the charge within the cube q. So we have to calculate these two quantities. First, second, we have given A is equal to 0.1 meter. A is equal to 0.1 meter. Side of this cube is 0.1 meter. So again, if we see this diagram, cube is kept at 0.1 meter from this origin. This is 0.1. And again side of the cube is 0.1. So that means this first end of the cube is 0.1 meter from origin. This another end of this cube, this second face of the cube is 0.2 meter. This is 0.2 meter. So let us simplify this diagram to understand this. So cube has 6 faces. Let us number them. This is 1, this is 2. 2 faces. 2 faces. Now 3 and 4, 5 back side and 6 front side. Okay. So this cube has 6 faces. 1, 2, third or top one, fourth bottom one, fifth backwards, and sixth is front. So what we see is that field is in x direction. So only faces this minus x direction or positive x direction. This face is 1 or 2. This face 1 and 2, surfaces 1 and 2 have either 0 angle or 180 degree angle with this E. Others have this 3 has a perpendicular, 4 has a perpendicular. This 5 and 6 has also perpendicular to electric field. So flux through this 3, 4, 5 and 6 would be 0. Why? E dot delta S is equal to 0. Why? Because cos is 90 degree. Cos 90 degree. So flux through these 4 surfaces would be 0. Only flux is because of 1 and 2 surfaces. Surface 1 and 2 which is not 0. Now let us calculate. Since the electric field has only x component, that means in this direction, for faces perpendicular to x, that means electric field has this direction, these four. The angle between E and delta S is plus minus pi by 2, as I have shown that cos is either 90 or 270. Therefore, phi is equal to E dot delta S is separately 0 for each face of the cube except two shaded one. So this one and this one, face 1 and 2, only these two are remaining which does not have a 90 degree angle. For this, let us consider this as left face L, this is right face. So now for this is given as Ex is equal to alpha x to the power half. This was the electric field. So the electric field is El on the left surface is alpha x to the power half, and the distance from origin is A, alpha a to the power half. This is for left one. For right one, the distance is A plus A 2A. So for right side, alpha x to the power half, alpha 2A to the power half. So this is for the right surface. Now left surface E dot delta S, this has an angle of 180 degree. So this surface normal is in this direction, outward normal, and the field is in this direction. So angle is 180 degree. So hence we write simply E dot L, surface area is A and A square. So this is simply comes as minus EL is this, minus EL into surface area A square, and minus is because of the angle 180 degree. For right side, this has 0 angle. 0 means cos 0, 1. So simply ER, and surface area is A square. So for right, simply ER A square. For left, minus EL A square. So let us calculate. So net flux is flux from the right side, flux from the left side. So if we put in this equation, so ER A square, this one is minus, so let us add them. So A square is common, ER minus EL, and this alpha is also common. And when we put the value of our right side, this is 2A to the power half, this is minus A to the power half. So when we calculate this is alpha A to the power 5 by 2, we took A also common, and in the root 2 minus 1, this is remaining, and putting the value of alpha 800, A value of A is 0.1 to the power 5 by 2, root 2 minus 1, this comes as 1.05 Newton meter square per coulomb. So since we are seeing that phi is not 0, that means there must be some charge inside this cube. Phi is not 0, that means there must be some charge inside this cube. So applying Gauss law, phi is equal to q upon epsilon naught, or q is equal to phi epsilon naught. So simply q is equal to phi is 1.05, so this is phi and this is epsilon naught. So we get a charge of 9.27 into 10 to power minus 12 coulomb. Why we consider a charge inside? Because phi was not 0. Phi was not 0, that means there must be some charge inside. And how can we calculate? Q is equal to simply phi epsilon naught. And now for calculating this, you have to use log tables or a scientific calculator. Thank you.